Hi everyone, and welcome back to the channel. So, these were the winners of an AI image competition back in 2020. Honestly, not super impressive. A little strange looking, not quite coherent, and definitely not realistic. Now, fast forward just 2 years and boom, photorealistic, AI-generated imagery is everywhere. The difference is night and day. But while everyone's been amazed by how far AI art has come, what most people don't realize is that something arguably more important has been quietly evolving in the background: AI language models. In a previous episode, we looked at a case where a Google engineer claimed that a chatbot had become sentient. That's how convincingly it could hold a conversation. In another case, Reddit users were unknowingly interacting with an AI for months without catching on. And it's not just language. Over in another corner of the tech world, Boston Dynamics and the Amica robot have shown us that robots can move with nearly human-level dexterity. It's impressive. So you can probably guess where this is going. What happens when you combine these two worlds, language-capable AI and physical robots? Well, Google just did exactly that. And the results? Genuinely fascinating. In today's video, we're diving into this breakthrough. How Google, through a collaboration with its subsidiary Everyday Robots, has created a new kind of robot. One that doesn't just execute pre-programmed tasks, but one that can understand what you say and respond accordingly. We're not talking about Siri or Alexa. This is way beyond that. These robots are capable of taking natural spoken commands and figuring out how to complete the task themselves. So, instead of hard-coding thousands of specific instructions, the AI understands language and learns to perform a wide range of tasks using that understanding. Here's how it works. Google took one of its most advanced language models and placed it inside a physical robot. And when I say brain, I'm not exaggerating. A 2022 study published in Nature found that these AI language models, like Google's, have internal processes that are strikingly similar to the human brain, particularly when it comes to predicting words from context. The neural patterns in these models actually mirror human brain responses to written sentences. In other words, the AI thinks a bit like we do. And that's kind of wild. So this robot has hands and eyes. The language model acts as its brain. The robot hears what you say and then works out how to respond. Not by following a script, but by reasoning. For example, you say, "I spilled my drink." The robot interprets the sentence, understands the problem, thinks of possible solutions, checks what it's capable of doing, and then physically carries out the task. That could mean picking up a towel, wiping the mess, throwing out the trash, and even bringing you a fresh drink. Pretty impressive, right? Now, that might sound simple, but under the hood, there's some seriously complex engineering. See, if you ask a regular language model what to do when you spill a drink, it might say, "Use a mop." But what if there's no mop nearby? Or what if the robot doesn't even know how to use a mop? That's where the challenge lies. Google's engineers had to teach the robot to understand its own physical limitations, what it can and can't do. They used a mix of AI, computer vision, and vast internet training data to connect the robot's eyes to its knowledge base. This allows it to see and understand what's around it. It can comprehend requests like, "I spilled orange soda. Can you clean it and get me another?" And it will break that down into multiple steps, analyze the scene, figure out how to move, identify tools it can use, and then act. At the core of this robot's intelligence is something called PALM, short for Pathways Language Model. This is a massive neural network trained on hundreds of billions of parameters, basically a ton of internet text. It gives the robot a deep understanding of language. But there's more. Another layer of code, called world grounding, helps the robot weed out actions that are unsafe, impossible, or just plain nonsense. It essentially filters out all the things the robot shouldn't even try to do. And to top it all off, the robot is trained with reinforcement learning. Every time it attempts a task, it's rewarded if it succeeds. If it fails, it's corrected. Over time, this constant feedback loop makes it smarter and more effective. Even better, much of the training happens in a virtual world, a simulator, which allows the robot to practice thousands of tasks without wasting time or risking damage in the real world. Thanks to this approach, Google managed to reduce the number of real-world practice attempts needed from 500,000 to just 5,000. That's a 100x improvement in training efficiency. According to Google's research, the robot correctly identifies the right sequence of tasks 84% of the time and successfully completes them 74% of the time. That's a 50% improvement over the previous best systems out there. Even better, as the language model improves, the robot improves alongside it. That's a promising sign of future progress. Google's own tests showed that these robots could follow complex instructions in a real kitchen using objects they'd never seen before. This isn't just a lab demo. This is happening in the real world. Right now, around 100 of these robots are performing tasks inside Google's offices. They roam the buildings, check trash cans, sort waste, and clean up. And they learn as they go, autonomously. The goal here isn't just to build robots that do one thing. The goal is to build robots that can learn new tasks on their own. So if a robot figures out how to pick a cup out of a bin, we can use that same process to teach it how to pick up, say, a phone, or a plant, or whatever. It's a system that gets smarter the more you use it. So what does this mean for us? Well, for one, this is a major milestone in the field of robotics. For the first time, a large-scale language model has been integrated into a real-world robot, and it works. Yes, right now, these robots are a bit slow. They're still limited to simple tasks and basic environments. But 10, 15, 20 years from now, we could very well be looking at full physical automation for entry-level jobs, like fast food, cleaning, or elderly care. But that's not necessarily a bad thing. These language-powered robots could also help us grow food, manage waste, clean up pollution, or even take care of people in need. The possibilities are endless. So, would I want one of these robots in my house right now? Probably not. But do I see the value in the research? Absolutely. If you enjoyed this episode, feel free to like, subscribe, and stay tuned for the next one. Thanks for watching, and I'll see you again soon. Cheers.